Today we're talking about graphing equations in slope-intercept form. However, we're going to break this lesson into two parts. The first part is not really going to be talking a lot about slope-intercept form, but talking about this important skill called slope. In the math world, whenever we determine how to get from one point to another point, we are calculating the slope. The easiest way is to look at the graph. That's going to be the easiest way when we are trying to calculate slope. But it's kind of simple, but it's an important thing to make sure we do correctly. We are going to be counting how many units you move up or down first. So if you think about it, moving up or down, that would be focusing on our y values. The y values, basically, if you think the y-axis, we're moving up by going up, positive, or moving down, being our down or negative. But that's what the y is controlling. Then we're going to count how many units you move left or right. This is basically what is happening on our x values. So then slope is always written as a fraction. Once in a while you'll see it as a decimal, but we really would rather see it as a fraction, basically because the way slope is written, the numerator is your up and down, which is the y values, and your denominator are the x change, or the x value that's going up, left or right. So really we'd like to see it as a fraction because it'll tell you your directions of how to get to the next point easier. So basically, what does slope describe? It basically is telling us the steepness of our graph. Some of our graphs are going to be much steeper than others. Some of them are almost laying flat. Some of them are laying flat. But the slope, when we look at a graph, is telling us how steep our points are in relation to each other. And again, the direction of the points and how to get to the next point is what slope is. Slope basically is referred to as two kind of things. It's the constant rate of change. We think of rate being like a speed, but it's kind of the same idea. We're thinking about how fast are my y's changing in relation to my x's. So it's a constant rate of change, and what the constant means is that that rate of change is not different between any 2 points on the graph. So I can calculate the slope between any 2 points of a linear graph, a perfectly straight line, and I will get the exact same slope between any 2 points on that line. The phrase we use, and you may have heard of in the past, is that rise over run. Rise rhymes with wise, so think of that when you're trying to remember which one goes where. So the rhyme is rise, rhymes with wise, over the run. So rise, when you think about it, you go rise up or rise down. That would be the y value. The run, you either run forward or you run backwards across the ground. So that would be your x's. Now, a couple of things here for formulas. So we use the letter lowercase m to represent slope in math. Now, here is the formula or formulas for what we'll be seeing slope as. So m equals, sometimes we'll just say that it's rise over run. So that's saying the same thing as m. We also will refer to it as your change in y over your change in x. And we'll refer to that in 1 second. Oh, I can see that I spelled change wrong in the numerator. I don't know if I can fix that easily enough, but let's just fix it. So we'll go back to change in y. So change in y over change in x. Another way we see it is this formula, which is the math technically formula. y2 minus y1 over x2 minus x1. Now you can see this here in the graph up above. So to find the run, you're taking these 2 points as x values and you're subtracting them. Now notice that the 2 and the 1 have nothing to do with an operation. They're really like a label. So x1 is part of one coordinate ordered pair, x2 is another ordered pair, and you're just subtracting the x's, and that becomes your denominator. Your rise will be taking care of the up or down, which means you're going to take the y value and subtract them. The tricky part is to make sure that you subtract them in the exact same order. So if I was to call this point the second point, which would be x2, y2, I need to make sure I take the y2 and subtract the y1 for my numerator. Then I go back and subtract the x2 and the x1 for my denominator. I have to make sure I follow this same order. Now, if I wanted to call this one x2, y2, that's fine. I could also get the same answer if I subtract y1 and y2, as long as I do x1 minus x2. And we'll see one of those coming up in a little bit. And then the other way that we're going to see this, and this is kind of the faster way to write this, so I probably will write this more often than these other ways, is if I use the Greek symbol delta, which looks like a triangle, delta y over delta x also means subtract your y values and divide it by the subtraction of your x values. So these all mean the same thing, just different ways of saying it. But y2 minus y1 over x2 minus x1 is kind of the technical formula for slope. I will probably be writing it or saying it a lot as delta y over delta x, which is also saying the same thing. So this next graph is just kind of showing us some different graphs of positive, negative slopes, zero slopes, and undefined slopes. And it's very important that we understand what does it look like as in general terms. So these pictures certainly aren't showing us the exact number answer for slope, which we'll be calculating later on. This is kind of showing us what we can look at when we see a picture or a graph. So looking at the very first one, the positive slope, I know that a graph is a positive slope if I see the line increasing or rising from left to right on the graph. It doesn't tell me how far and how fast it's increasing, but it's definitely increasing, meaning that the left part of my line is lower on the left than it is on the right. So it's definitely climbing of some sort. That tells me that I know I should have a positive slope. Compare that to the next one. We see that now it's falling from left to right. I am clearly a lot higher on the left side of the graph than on the lower right-hand side of the graph. So as I read my graph from left to right, if it's climbing, it's a positive slope. If it's dropping, it's a negative slope. So they're going to keep those two things in mind. They kind of help us confirm as a rough check. Should it be a positive slope? Yes. Should it be a negative slope? Yes. And then we can figure out the numbers after that. But then we have the difference here between these next two. So we can see that this is a horizontal line. So I want you to think of a horizontal line is like the floor. If you think of it, we're all sitting right now someplace on a floor, whether it's a chair on a floor, couch on the floor, bed on the floor, wherever. The floor, if it's done and built correctly, should be perfectly flat. Then, when you think about it, I can walk across the floor. There's no steepness to it. It's not going upwards. It's not going downwards. It's perfectly flat. That tells me every horizontal line is a slope of a 0. Now compare that to the vertical line, which is next. Think of the vertical line as the wall. It goes perfectly straight up and down if the house or building is built correctly. If you think about that same walking idea that we just did across the floor with no going up or going down, you can't walk up a wall. At some point, gravity is going to pull you back down, even if you think you can get a few feet up. So when we have the vertical line or the wall, it's very important that we make sure our answers are undefined slope. The other way you can answer this is no slope. But it's very important that we understand the difference between these two things. A slope of a 0 is perfectly flat. There's no steepness to it. It's perfectly flat. The vertical line has no slope. And again, if you think of that analogy, you could try to walk up this thing, but you're going to fall back down. Whereas this one with no steepness, you could just keep walking without any kind of problem. It's important that you understand those two things. So let's look about how do we find slope. So kind of the way the book has put these diagrams in, I don't love, but I'm going to try to show you how I would find slope in this graph. So when I look at my rise, first they want me to say, what is the slope of this line in general? So can we all agree that we see this point here much, much lower on the left than this point over on the other side? So first, we can see that it is definitely rising from left to the right. So we know that this is a positive slope for sure. Now, what kind of a slope is this? Well, if I look at my graph, I would focus on the rise first and then the run. So I'm going to use this formula. So I'm going to start at this point right here. So my rise is, if from this point, I'm going to go up 1, 2, 3, 4 to get to the same height as that other point, 3, 2. So we went up 4. So that means on the numerator, I have a 4. Then when I switch over to my run, this time I'm going to start at this point up top here. 1, 2, 3, 4, 5, 6 to meet the other one. Now because I'm going to the right, this is a positive 6 run. So there's the 6 down there. Now we're very happy leaving our slope as a fraction. The only thing that I would need to make sure I do is reduce it. So my slope is 2/3. Now why I don't love how this works is the way they did it was they started here and they did their run first and then their rise. So what I want to do is use kind of their work but backwards. Just real quickly, and I don't want to confuse people on this too much, but I just want to show you how you could have done this a different way. So let's just say I wanted to start at this point over here this time. So if I did my rise first, I would have gone 1, 2, 3, 4 down, which is a -4 for my rise. And then I would have turned and gone this way 6 units to the left this time, which is a -6. But think about that. If I make a -4 for my rise, -6 for my run, doesn't that still come out to positive 2/3? So I just want you to notice that it doesn't matter which point I start from. Any 2 points give me that constant rate of change. And it's important that we can kind of understand that as we go forward. So looking at the next one. So first we want to answer, is this a positive or a negative slope? Well, clearly we are falling from left to right, which tells me that this is a negative slope. Okay, so we want to keep that in mind. So our answer somehow comes out positive. That would tell me to relook at my numbers. Okay, so that same rise over run. So again, I will start with this point right over here on the left. You don't have to. You can start on the right side. We just proved also. I'm going to come down 1, 2, 3. So there is my numerator. The rise was a -3. And then I'm going to turn and I go forward 2. So it's a +2. And then obviously negative 3 over 2 is negative 3 halves. There's my slope for this one. So now we have finding our slope from a table. So we don't have a graph this time. We can't just use the coordinates on the graph to see what this looks like and to kind of just count boxes. I certainly could graph these tables. I could plot these points, see the line, and go from there. But we can also do this from the table. So remember, my y value, rhymes with y's, would be the y's, and the x is the run. So because we are told that this is a line, they lie on a line, I should have a constant rate of change. So again, we're going to be looking for rise over run. So first, let's focus on the y's and the rise. So what I want to think about is, how does 20 become 14? Well, I would subtract 6. How does 14 become 8? I would also subtract 6. How does 8 become a 2? I would also subtract 6. So it looks like my rise is a negative 6. As far as the run goes, I have to go in that same order, plus 3, plus 3, and plus 3. That tells me that the rise and the run are a constant rate of change right now. We have negative 6 over 3, which gives me a negative 2 slope. Looking at the next one, again, the y's rhyme with rise. And I would say on this one, how do I go from here to here with addition, subtraction? It is plus 0. It is plus 0. It is plus 0. The run is going to go plus 2, plus 2, plus 2. So I get the rise of a 0 over the run of a 2. 0 divided by 2 is 0. And again, that is going to give me the horizontal line. You can verify that by graphing those points, and you're going to have a horizontal line sitting at 2, because every one of those ordered pairs is y is a 2, y is a 2, y is a 2. It doesn't climb or drop. And then the last one, we would say here we see a plus 3. We then see a plus 6. And lastly, we see a plus 3 again. But notice over here for our run, I'm just seeing plus zeros all the way down. So now this time, just notice that we have a rise, which is changing a little bit, which, that's just because of how the order pairs are put down. But the run is very consistently and steady a 0. So can we divide by 0? Well, in math, we cannot. When we divide by 0, we get this term undefined. So you are not allowed in math to divide by a 0. It is called undefined, or we can just say no slope. Now again, we talked about this a little bit earlier. These are your vertical lines. So you would answer this as your slope is undefined or no slope. Just like over here, you would have answered your slope is a 0. The rest of this video will pick up next week, but this is the start of this video. This is a very important concept, understanding how to find slope, understanding that the slope of a horizontal line is going to be 0, and that the slope of a vertical line is undefined or no slope.